Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with the orthographic projections of the solid, and using the information available to us through these three orthographic views, that is front view, top view and the left hand side view, we are required to construct the isometric projections of the solid. And in the isometric projections, the three faces of the solid, that is the front face, top face and the left hand side face. So all the three faces, they will be clubbed into a single 3D isometric projection construction. And in order to develop this isometric projection, we need to evaluate the dimensions of the front face, top face and the side face of the solid. So when we observe the solid in the front view, so we find that the length of the solid happens to be 48 millimeter, while the height of the solid, it is equal to 48 millimeter. So the front view face will be having the dimensions 48 millimeter by 48 millimeter. Similarly, from the top view, we are going to observe that the length of the solid, it is again equal to 48 millimeter, while the width of the solid happens to be 48 millimeter. So the top view face will be a square face having an edge equal to 48 millimeter. Finally, when we look at the solid from the left hand side, so we observe that this is the width of the solid, and this width of the solid, it is equal to 48 millimeter. So this distance we are going to get from the top view projection over here, and the height of the solid, it is equal to 48 millimeter. So the side view face will be again a square having edge equal to 48 millimeter. Now since in this orthographic projections we have been provided with the left hand side view which has been drawn on the right hand side of the front view, we have to observe the solid from the left side. So if we have to observe the left hand side view, we are going to get the left side view will be drawn onto the XY plane over here, that is onto this side X and Y plane over here. We are going to get the construction of the side face, which is the left side face of the object. So if this is the direction of the left side face, then the front view will be lying on this side. So we are going to draw the front view of the solid along the YZ plane over here. So this is the isometric Y axis and this is the isometric Z axis over here. So within this YZ plane, we are going to carry out the construction of the front view of this object over there, and the top view, it will be drawn within this plane, that is the X and Z plane over here. So within the XZ plane, we are going to get the construction of the top face or the construction of the bottom face of this solid. So on either side it will be 48 millimeter. So all the dimensions, that is the length, it is the length over here, width, it is 48 millimeter over here. All the dimensions which will be projected in the isometric construction will be equal to 48 millimeter. That is the length of the solid as it is shown in the front view, this will be 48 millimeter. The height of the solid, which is again equal to 48 millimeter, it will be shown along Y axis, and the width of the solid, which is equal to 48 millimeter, it will be constructed along the X axis over there. Let us first of all discuss the geometry of this object. As we can see over here, this component has been divided into three segments. If we look at this component from the front view, so we are going to get these three segments. They will be having the length equal to 16 millimeter each, and similarly from the top view, we are going to get three segments over here even in the top view. So we are going to get three rectangular segments in the front view and three rectangular segments are there in the top view. And another thing we can see over there, which we can find out from the left side view, that there is a inclined surface over here. So since this inclined surface happens to be dotted, that is, it is drawn with the help of a hidden line in the orthographic projection, so it means that this inclined surface is corresponding to the interior web, which is going to lie at the center over here. So we can say that this web, which is shown as the interior web in the front view as well as in the top view, this web will be an inclined one, whereas the outermost two webs of the solid, so these are two vertical webs, one on the left side and another one is lying on the right hand side. So this web which is going to lie on the left hand side, and there is another web which is vertical one, it is going to lie on the right hand side of the solid. So both of these webs, that is the external webs of this particular solid, they will be a square web. So you are going to get square webs on the left hand side and the right hand side, whereas in the interior portion, that is in the middle portion, we are going to get an inclined web starting from this point and it will be ending up over here. So this way we can conclude the discussion regarding the geometry, that in this component there are two vertical webs over here which are the external webs, and these webs will be the square one. How do we conclude that these two external webs, they are square? Because in the front view the height is equal to 48 millimeter, and similarly in the top view also, corresponding to these external webs, we have got the width equal to 48 millimeter. So this web and this web, that is the web on the left and on the right, they are the square webs, whereas this internal web, it is the inclined one, because we are going to get a dotted projection corresponding to this interior or the middle web on the left hand side view. So in order to draw the isometric projections of the solid, we need to first of all construct the isometric scale and all the distances regarding the different edges over here onto the orthographic projections. So these dimensions, they will be first of all drawn onto the true length scale, and the corresponding isometric lengths, they will be evaluated. And once we convert all these true lengths from the orthographic projections into the isometric length, only then we can start with the construction of the isometric projections of the solid. Let us now start with the construction of the isometric projections of the solid. So step number one, we have to draw the horizontal ground line or the datum line over here. So this is the horizontal ground line that we have constructed, and onto the horizontal ground line we are going to mark the origin point. So this is our origin point, and from the origin point, isometric x-axis will be constructed towards the left side, which will be drawn at an angle of 30 degrees with respect to this ground or the datum. Similarly, the z-axis, which will be an isometric z-axis, will be constructed at an angle of 30 degrees with respect to this ground onto the right hand side direction, and the height of the solid will be constructed along this y-axis, which happens to be perpendicular to the ground. So the isometric x-axis, y-axis and the z-axis, they have been drawn. And as we have already discussed, onto this side we are going to draw the front view face of the solid. Onto this side we have to draw the left hand side view face of the solid. So regarding the front view, we know that the length of the solid happens to be 48 millimeter. So this is the length of the solid, equal to 48 millimeter, and the height of the solid happens to be 48 millimeter. So this length has been drawn along the z-axis and the distance has been marked as 48 millimeter. So this is the 48 millimeter length over here, and the y-axis contains the height of the solid, which is equal to 48 millimeter. So once we complete the square face on this right hand side, so we have to draw this isometric edge parallel to the z-axis, measuring 48 millimeter, and another isometric line or the edge we have to draw parallel to the y-axis, and this edge will also be measuring 48 millimeter. So this is our front view face of the solid. Now this is the left hand side face of the solid. So in the left hand side face, the width of the solid happens to be 48 millimeter. So this width equal to 48 millimeter has been drawn along the isometric x-axis, and then the height of the solid, it is also equal to 48 millimeter. Now in order to complete the left hand side face, we have to draw an isometric edge parallel to the y-axis measuring 48 millimeter, and another isometric edge we need to draw parallel to the x-axis. Again this edge will be measuring 48 millimeter. So the left hand side face of the solid has been completed. Now we need to complete the top face of the solid. So the top face of the solid is again a square shaped surface having the dimensions 48 millimeter by 48 millimeter. So now one more isometric edge will be drawn parallel to the z-axis measuring 48 millimeter, and another isometric edge has been drawn parallel to the x-axis, so that we get a square top face having edge equal to 48 millimeter. We are going to have a square side face having edge equal to 48 millimeter, and a square front face has been obtained which is again measuring 48 millimeter. Now we need to draw the bottom face of this particular solid. So in order to draw the base of the solid, so one more isometric edge parallel to the y-axis has been drawn, and this edge will also be measuring 48 millimeter. Then another isometric edge which will be drawn from this point which will be parallel to the z-axis, and this will also be measuring 48 millimeter. And finally an isometric edge has been drawn parallel to the x-axis, and this edge will also be measuring 48 millimeter. So we have been able to draw the cube over here. So this is a cube having edge equal to 48 millimeter, and this cube shaped object, it is going to contain all the elements of this particular solid. Now we have to translate the information from the orthographic views into the isometric projection. The three faces of the solids, they have been drawn over here. Now we know that in the front view, as we have already discussed, that there are three webs over here. This web is vertical, this web is vertical, while this web happens to be inclined web. But the length of each web over here, it is equal to 16 millimeter. So please check what we have done. We have marked distances of 16 millimeter on the top surface, so that from the front view we will be able to get these three webs over there, because even from the top these three webs, they will be available. So in the top view it will be this face. So onto this face, the top face of the web, they are going to lie over here. So this surface and this surface of the two webs, they will be lying horizontally onto the top face, and this surface and this surface which is available in the front view, they will be located in the front view in the form of a vertical web over here, and this inclined surface will be starting from here and it will be ending up over here. So these will be the two slant surfaces which will be available to us in the middle. So let us start with this construction. So as we can see, length of the external web, it is 16 millimeter from this end, and another length corresponding to this external web from the other end of this particular solid, it is 16 millimeter from this particular end. So we have marked these two edges over here. So these two projection lines once we draw, so please check what we have been able to identify. We have been able to obtain the horizontal component of the web number 1 and the horizontal component of the web number 3. So the horizontal component of web number 1, it is this one. This has been obtained, and the horizontal component of web number 3 has been obtained. Now we are going to take these projections down vertically. So once we take these projections down vertically, now the vertical component, please check, the vertical component of the first web which is visible to us in the front view, it has been developed over here. Similarly, the vertical component of the web number 3, vertical web, which is a square web, so this has been drawn as it was observed in the front view. The combination of the front view information and the information from the top view to develop the two external webs over here, which are square webs over there, right? So these are the square webs. Now we need to draw the inclined surface over here. There is an inclined web. The internal web, it is not this one. The internal web, it is not straight, rather it is inclined. So from this point, we need to join this point. From this point over here, we need to join this point. So how did we derive this information? Because in the left side view, we can check that there is a dotted line or a hidden line. So hidden line is corresponding to the surface of this middle web. So this is a middle web which is an inclined web. So inclination is such that it starts from the rear face over here and it will be moving down from the top portion of the rear face to the bottom of the front face over there. So this is going to be an inclined web. Now please check, I have drawn this inclined web from the back side. I did not draw another line over here. The reason, because this face, this has been covered by the rectangular web which is lying over here. Even for this particular inclined edge, we have worked out that certain portion of this inclined surface, it has already been covered by this vertical web. So even this inclined line corresponding to the inclined middle web over here, it is not going to be visible to the observer. So this portion of this inclined web, this will not be visible to the observer. Now web number 1, which is the vertical web, it has been observed. Web number 3, which is again a vertical web, has been obtained, and the web number 2, which is the interior web, which is an inclined web, so this has also been developed over here. Now we are going to start with the darkening process of whatever edges they are visible to the observer. So here we can see the base of this solid, it is visible to the observer, it has been darkened. So this edge, vertical edge, and this vertical edge corresponding to the left hand side face, so they are visible to the observer. So this edge and this edge, they have been darkened. And finally from the side view, we can also see that the top edge is also visible to the observer. So this top edge has also been joined as a darker one or with an object line over here. Now looking at this object from the top, so we can see that in the top view, I am able to see all the 4 edges over here as dark ones, right? So this part I am able to see over here, whereas this portion, it is visible to us as a straight line in the top view. So even though this portion is empty over here because this is an inclined web and the upper portion of the inclined web has been removed, but when we look at the solid from the top, so this edge and this edge, they will be appearing to us as a straight line in the top view. Now when we look at the solid over here, then the front web is visible to us in the front view, that is the web number 3. So the front web, that is this web number 3, it is visible to us in the front view. Similarly, I can darken this one also. So the web number 1, it is also visible to the observer in the front view. And this is a true shape, this is also a true shape, this is a true shape, this is also a true shape. So true shape of surface 1, surface 2, they are available over here. True shape of surface 3 and surface 4, they are available over here. But this is an inclined surface over here, that is the middle web. So this inclined surface, we can see that it is a much bigger or a longer surface because it is inclined to HP as well as the surface happens to be inclined to HP. So the projections of the surface on the vertical plane as well as the projection of this inclined surface on the horizontal plane will be appearing as the apparent shapes over here. So this is also apparent shape. This surface, that is the middle surface, it is also an apparent shape. So this completes the construction. Now, in order to show this inclined surface, I need to join this portion of the inclined web and I need to join this portion of the inclined web. So this portion of the inclined web has been covered by this square vertical web over here. So that is why I did not join it straight away. Now I am also going to join this point with this point so that we can just have a feel. You see, with a very minute thin line over here, it is a thin minute construction line which is going to provide me a feeling that this is also a rectangular surface, right? So if I do not draw this line over here, so I will not be able to understand that whether or not I am going to have this inclined rectangular web over here. So this particular line should not be drawn otherwise, because in the isometric projections we do not consider or we do not draw the hidden line. It is only for the purpose of understanding that I have drawn this hidden line over here as a construction line over here. So this edge has been drawn only to develop this understanding that there is a rectangular inclined web lying right in the middle of the solid. So now I am going to remove this line, because usually we do not draw the hidden lines in the isometric projection. So this is the final construction of the isometric projections of the solid once the three orthographic views of the solid they were provided to us. So I hope that through this discussion you would have understood about the procedure to develop the isometric projections of the solid from the orthographic views. So this is all for today. So we will be continuing with further discussion on few more cases of the isometric projections in the coming lectures. Thank you very much. Thanks a lot.